L140 Residential Applications Objectives. Under the supervision of your instructor, you should be able to do the following. Properly install a master and companion light control. Tools: 1 Phillips screwdriver, 1 flathead screwdriver, 1 pair of diagonal cutters, 1 pair of wire strippers, 1 needle nose pliers, 1 voltage tester, non-contact, 1 utility knife. Materials: 2 3-way switches, 2 plastic single-gang boxes, 1 4-0 side nail plastic box, 1 6 feet pigtail cord for power, 15 feet of 14, 2 Romex, 10 feet of 14, 3 Romex, 9 wire nuts, 1 roll of black electrical tape, 1 keyless fixture, 1 light bulb.
Let's start our presentation.
All right, welcome back, EL 140 Residential. We got Unit 2, Meeting 1. We're going to be covering objectives for switching lab, 3-way dimmer, master and companion dimmer. I also got set up here a simple 3-way circuit, our normal standard. Here in the illustration, I got my master dimmer, companion dimmer. The setup is the same as we do our standard 3-way switching. You can see here from the manufacturer, they give us a QR code, they give us a video that accompanies that if we want to go to that extent. I like my students to look at everything that the manufacturer provides. I'd rather them learn from a manufacturer than some untested, reliable source that might just be online somewhere. So I always illustrate to them the pictorial, the line diagrams, make sure that they can read it, make sure they can interpret it. If they have no problem doing that or drawing their own circuit, they have no problem putting it together. It's always a good practice to always bring out your meter with every lab, making sure that you're giving your students adequate amount of time to go ahead and test out circuits with their meter, utilizing their meter for continuity checks, making sure their grounding system's intact. You can hear the tones there. When it comes to our ungrounded conductor, we can see if it's going to make it through here, and we'll get a flip of a switch there. Sometimes when you're pushing in through a wire nut, you got to make sure that you're all the way in. So when you do that, if you have a bad connection or you have a bad wire nut, that's not a good thing. You got to make sure that you're always deep. Get it in there. See if we have a connection there. Boom. Okay, got a connection at the first 3-way. Second 3-way. It's going to require a flip of a switch, and there we are. We also want to check between the two. Now I got my probes on both of the commons, and I want to make sure that they're both working, the switches, together. That they're wired correctly, and making sure that one with each toggle flip is making that tone appear or disappear. That's going to determine whether our switches are really working well together and they're wired correctly. In the case of, these are our standard 3-way. Now we're going to move over to the unit here where we have the dimmer controlled ones, the master and the companion.
Answer the following question. Why is it important to use a meter for continuity checks before energizing a 3-way dimmer circuit? A. To verify the brightness level of the dimmer. B. To detect shorts or wiring faults before powering the circuit. C. To measure the voltage output of the dimmer. D. To confirm the brand of the dimmer switch. The correct answer is B. To detect shorts or wiring faults before powering the circuit. Explanation. Using a meter for continuity checks helps identify shorts, open circuits, or ground faults before energizing, preventing damage or safety hazards. It ensures the circuit is wired correctly and safe to operate. Let's continue with our presentation.
With that same setup and the same wiring configuration, You can see here that we're energized. We got our LED indicator showing us that it's at full strength. We can dim it. Obviously, you got to explain to your students some light loads are undimmable to a certain extent, maybe to up to like 10%. When you get to a certain level, sometimes they start to blink. There's like a little fading away. So we're down at the lowest level right now, and we're not getting any blinking, so that's a dimmable bulb. We can bring it back over here up on the companion, and alternately the dimmer LED master over there is showing us as we're increasing as well. So that shows the communication as well between both switches. We also got a push button off, push button on, and it'll go down and dim to a stop. And then it'll rise here. It'll start at the bottom and quickly accelerate to the highest level. So those are little things, nuances you want to explain to them. With the onset of a lot of smart switches nowadays, we might be having more neutrals coming into contact with switches. So we got to explain those concepts. That's why it's always very important, because things are always evolving really fast in the field and with manufacturers, to read that spec sheet. And for us to read it to them and break it down to them, interpreting all the nuances of trade terms and the technical language. So making sure that your circuit operates in a way that demonstrates not only does it dim, but they're obviously opening the circuit, closing the circuit. But before you energize in the lab, always even here, give it that observation. If they put it together, give it that observation inspection. Do your continuity checks to see if you got any shorts, any ground faults. Making sure that we get that same communication between the switches before we energize. All right, we'll leave it there. I'll see you guys in the next lab. Have a good one.
Review question. If a dimmer-controlled light starts blinking when dimmed below 10%, what is the most likely cause? The answer is, the bulb is not designed for low-level dimming. Explanation. Some light loads are not fully dimmable below certain levels, causing flickering or blinking. This is due to the electrical characteristics of the bulb not supporting very low power levels.